Good morning, everybody. I introduce myself. My name is T. Henson. I am working as assistant professor in the Department of Mathematics, St. Joseph's College of Arts and Science, Cuddalore. I am going to teach allied mathematics for first BSc chemistry. Unit 4, topic double and triple integrals. Now we are going to evaluate this double integral. So double integral 0 to 1 x square plus y square into dx dy. First we take this double integral as I. Here we have to integrate this with respect to x first because we have dx as the first expression. Here we integrate with respect to x first. So here we can split this integral like this, integral 0 to 1, integral 0 to 1 x square plus y square into dx. When you integrate this with respect to x, except x, all other terms are constant. Here y square is constant. So if we integrate x square with respect to x, we get x power 3 by 3 plus here y square is constant. So integral y square into dx is y square x. Limit 0 to 1. Here we have dy. Then we have to apply the limits, upper limit minus lower limit. And that is to be applied for x. So 1 by 3 into y square into 1 y square. Then 1 by 3 plus y square into dy. So next we have to integrate this expression with respect to y. Here the limit 0 to 1. So when you integrate this with respect to y, except this y, other terms are to be considered to be constant. Here 1 by 3 is constant. So integral 1 by 3 into dy, we get 1 by 3 into y plus if you integrate y square, we get y power 3 by 3. Here we get y by 3. So limit 0 to 1. When you apply the limits for y, that is 1 by 3 plus 1 by 3, that is equal to 2 by 3. Right. Next problem, triple integral 0 to 1, 0 to 2, 0 to 3, x plus y plus z into dx dy dz. So first we take the given integral as I. We can split this triple integral like this. First we have to integrate with respect to x. Here if we integrate x, we get x square by 2. Here y is constant. If we integrate y, we get yx. Plus z is constant. If we integrate z with respect to x, we get zx. Here limit 0 to 3. Here we have dy and dz. So now we are going to apply the limits x, upper limit minus lower limit. Here we substitute the upper limit 3 for x, then minus, then we have to substitute 0 as a lower limit for x. When you apply the upper limit 3 for x, we get 3 square by 2, that is 9 by 2, plus 3 into y, plus 3 into z. So when you apply the lower limit, we get 0. We need not write that 0. So we get this result after applying the upper limit. So 9 by 2 plus 3y plus 3z. Next we have to integrate this with respect to y. When you integrate with respect to y, except y, other terms are considered to be constants. So here 9 by 2 is constant. So 9 by 2 into integral dy, that is 9 by 2 into y. Plus when you integrate 3y with respect to y, we get 3y square by 2 plus 3 into, if we integrate z with respect to y, we get zy. Here limit 0 to 2 into dz. Here we have to apply the upper limit 2 for y because we have integrated with respect to y. So we have to apply upper limit 2 and lower limit 0 for y. Now we are going to apply the upper limit 2 for y, that is 9 by 2 into 2 plus 3 into 2 square, that is 4. 4 into 3, 12. 12 by 2 plus 3 into, now we have to apply the limit 2 for y. So 3 into 2, 6. 6 is when you apply the lower limit 0 for y, we get 0. So we need not write that term. So into dz. Next we have to integrate this with respect to z. So before integrating this expression, now we have to simplify first. So we can cancel this 2, here we get 9. Here we can cancel this 12 by 2, that is 6 plus 6 is there. So next so we have to integrate this with respect to z. Here 9 is constant. So when you integrate this 9 with respect to z, we get 9z plus 6z plus 6 into z square by 2. So now we have to apply the limits for z 0 to 1. So 9 into 1 plus 6 into 1 plus 6 into 1 square by 2. So 9 plus 6 plus 3, that is equal to 18. So this completes the second problem. Next third problem. Evaluate this double integral 0 to 1, 0 to 2 x square plus y square into dy into dx. So here we have dy. So first we have to integrate with respect to y. We can split the given integral like this. So I equal to integral 0 to 1, integral 0 to 2 x square plus y square into dy. Here a dx. And now we have to integrate with respect to y. When you integrate x square with respect to y, we get x square into y. Plus, if we integrate y square with respect to y, we get y power 3 by 3. So limit 0 to 2 into dx. Now we have to apply the limits for y. Upper limit 2, lower limit 0. We can apply the upper limit 2 for y. Here we get 2 into x square plus 2 cube, that is 8. 8 by 3. So 8 by 3. When you apply the upper limit 2, we get this result. Next, we have to apply the lower limit 0 for y. So when you apply the lower limit 0 for y, we get 0. We need not write that value. So here we have the remaining terms 2x square plus 8 by 3 into dx. So we have to integrate this expression with respect to x with the limit 0 to 1. So when you integrate with respect to x here, 2 into, when you integrate x square, we get x power 3 by 3 plus we have to integrate 8 by 3. 8 by 3 into integral dx, that is 8 by 3 into x. Now we have to apply the limits, upper limit 1, lower limit 0. So when you apply the upper limit 1 for x, we get 2 by 3 plus 8 by 3, that is equal to 10 by 3. When you apply the lower limit 0, we get 0. We need not write that value. So here the answer is 2 by 3 plus 8 by 3, that is equal to 10 by 3. So this completes the third problem. Now we are going to see the fourth problem. Evaluate double integral 0 to pi by 2, 0 to pi by 2 sin x plus y into dx dy. First we take the given integral as I equal to integral 0 to pi by 2, integral 0 to pi by 2 sin x plus y into dx dy. Here we have dx first, so we have to integrate with respect to x. So when you integrate with respect to x, the other term y can be considered as a constant. So if you integrate sin of x plus y with respect to x, we get minus cos of x plus y with the limit 0 to pi by 2. So here we have dy. So we have differentiated this sin x plus y with respect to x, we get this result. Now we have to apply the limits, upper limit pi by 2, lower limit 0 for x. So that is minus cos of pi by 2 plus y, then minus of minus plus lower limit 0. So cos 0 plus y, cos y into dy. Right. Now we have to simplify this. Here minus cos of pi by 2 plus y is nothing but sin y. Plus cos y we write as it is. Now we have to integrate this with respect to y with the limit 0 to pi by 2. So if we integrate sin y with respect to y, we get minus cos y. Plus if we integrate cos y with respect to y, we get sin y. Limit 0 to pi by 2. Now we have to apply the limits for y. Upper limit pi by 2, lower limit 0 can be applied for y. So minus when you apply the upper limit pi by 2 for y, we get minus cos pi by 2 plus sin pi by 2. So the upper limit is applied. Minus lower limit 0 should be applied for y. So minus minus cos 0 plus sin 0. Now we have to write the values for cos pi by 2, sin pi by 2, sin 0, cos 0. So cos pi by 2 value is 0 plus sin pi by 2 value is 1. 0 plus 1 minus here cos 0 value is 1. So minus 1 plus sin 0 value is 1. So sin 0 value is 0. So minus 1 plus 0. Here minus 1 plus 1. So 1 plus 1 equal to 2. So this completes the problem. Fourth problem. Next, fifth problem. Evaluate double integral 1 to 2 x2 x into root 3 xy dy into dx. So first we take the given integral as I. So integral 1 to 2 integral x2 x into root 3 xy dy into dx. So first we have to integrate with respect to y. So when you integrate with respect to y, except y, the other term x will be considered as a constant. So if you integrate xy with respect to y, we get x into y square by 2. Limit x to x into root 3. So now we got to apply the upper limit for y. Here x into root 3 square. X into root 3 square is 3x square by 2. So minus, when you apply the lower limit for y, x into x square by 2. So upper limit minus lower limit we have applied here. Next, we have to simplify this. Here are 3x cube by 2 minus x cube by 2. Limit integral 1 to 2. When you simplify this, we get 3x cube minus x cube, 2x cube by 2. We can cancel this 2. So we get integral 1 to 2 x cube into dx. When you integrate x cube with respect to x, we get x power 4 by 4 with the limit 1 to 4. Upper limit is 2, lower limit is 1. So we can apply the upper limit to 2 for x. We get 2 power 4, that is 16. 16 by 4 minus lower limit, that is 1 by 4. That is when you simplify this by taking a LCM. LCM is 4. Here we get 15 minus 1, that is 16 minus 1, that is 15. So 15 by 4. This completes the fifth problem. Then sixth problem. Evaluate double integral 0 to 1 x square to 2 minus x xy into dx dy. First you take the given double integrals I equal to integral 0 to 1 x square to 2 minus x xy into dx dy. The first limit is given for y. So we have to integrate with respect to y first. Right. Now we have to integrate this with respect to y. When you integrate with respect to y, except y, the other term x can be considered as a constant. Right. So when you integrate this with respect to y, we get x into y square by 2, limit x square to 2 minus x. Now we have to apply the upper limit minus lower limit for y. So here we get this result, x into 2 minus x whole square by 2 minus x into here lower limit, that is x power 4 by 2. So when you simplify this, x power 4 into x power 5 by 2, here when you expand, here we have to expand by using a minus b whole square formula. Then we can multiply this term by term, we get this expression. Then by taking LCM, we can take it out 1 by 2. Then after that, we can integrate this whole expression with respect to x. So when you integrate this expression, we get this result 1 by 2 into 4x square by 2 plus x power 4 by 4 minus 4x cube by 3 minus x power 6 by 6 with the limit 0 to 1. So when you apply the upper limit 1, we get this expression. We can get this expression. When you apply the lower limit 0, we can get 0. We need not write that value. So after applying the upper limit, we get this expression 1 by 2 into this expression by this expression is obtained by taking LCM. That is LCM is 12. Here we get a 24 plus 3 minus 16 minus 2. When you simplify this, we get 1 by 2 into 9 by 12. That is equal to 9 by 24. That is equal to 3 by 8. This completes the 6th problem. So thank you.